All right, so good evening, everybody. I just wanted to do this video. I would like to say real quick, but I'm going to take my time. Just again, not because I don't think you as parents don't know how to do this. I don't want to assume that. I just want you to hear how I do these kinds of problems in class, and kind of the terminology and the silly things that I say to help them remember how to do these steps or these problems. And I'm going to start off with just simple long division just to show you when we're doing this the kind of terminology I use. So since we are talking about ratios, I've set these up as ratios first. So this first one, I hope you guys can see this. It's been a while since I've done this on one of these image mates, but I always tell them, I remind them of Abraham Lincoln's quote of "a house divided amongst itself cannot stand." And I tell them that just to remember which number is the dividend and which one's the divisor, or which one goes in the house and outside the house. So I always tell them read up to down or high to low. So it's like saying a house divided amongst itself cannot stand. And the rest of it doesn't really matter. It's mostly just a house divided. If you can remember a house divided, then you know how to set it up. So that's how we always know if they're working with ratios or rates or whatever, and they need to divide a fraction, because we talk about how fractions are division. It's just saying 48 divided by 3. Well, a house divided by 3. So that's one thing we say if they're having troubles with that. So for actual long division, I'm going to come over here and write this down. I'm going to write the DMSC B. Some of y'all might be familiar with this. The acronym, we're going to say it stands for Does McDonald's Sell Cheeseburgers? Okay, some people have just heard Does McDonald's Sell Burgers, but I always say I like to throw some cheese on there, and we'll talk about that. So the D stands for divide. That's the first step. So you always say, how many times can 3 go into 4? Or how many groups of 3 can you divide 4 into? Whatever way you can think of to say it, I would just say, how many times does 3 go into 4? They usually say 1. And a couple things, like I said, I'm going to go slow on these, really emphasizing what I say in class. And the first thing is make sure you are lining up your place values. 3 doesn't go into 48 one time. I'm not throwing my 1 over here, or I'm not throwing it over here. I'm putting it directly above the 4, because that's how many times 3 goes into 4. So that's the divide. The McDonald's, or M, is for multiply. 3 times 1 is 3. And although it takes up space, I always say each number deserves its own line, and it helps us keep those place values lined up. That's multiply. Then we get to does McDonald's sell, or subtract. 4 minus 3 is 1. And this is where I like to throw some cheese on there. I call it check. And what you do is you check to make sure that your difference of your subtraction is less than your divisor. Sometimes kids will think that 3 goes into a number a certain amount of times, and when they get down here they might get 3 or 4 as their difference, which means it really could have gone into this number more times. So 1 is less than 3, so we're good there. And the burgers, or the B, is bring down. And that's when we bring down the 8. And then we just restart the process. Does McDonald's sell cheeseburgers? So D is divide again. Divide 18 by 3. How many times will 3 go into 18? You guessed it, 6 times. And I always say if you know it goes in evenly, you can stop there. Or if you're just someone who likes to make sure they do everything, you can go ahead and go through the process. Say multiply, subtract, check. 0 is less than 3. Once you get 0 as your difference, you're done. All right. Now, that was basically how I walk through a normal division problem. Here we have 72 over 5, which is 72 divided by 5, which is a house divided by 5. A house divided by 5. I know that's really silly, but hey, it helps some students remember. So we're going to go through the process again. You're going to notice that 5 is not a factor of 72, however, so this is where a lot of our students are struggling right now. And likely so, because they're not necessarily used to going to the decimal. But it should have been something that they're not completely foreign to. 5 goes into 7 for our division one time. We multiply for McDonald's. We subtract for cell. Again, lining up all place values, super important. Please make sure your kids are doing that. We're going to check, is 2 less than 5? Yes, it is, so we're good. Now we can bring down the 2. You can put the arrow or not. If you put it, just make sure it's neat as possible. And now we restart. 5 goes into 22. 4 times. Multiply. Get 20. Subtract. Get 2. Is 2 less than 5? It is. That's our check. And then we bring down. I said you have to have 0 as your difference to be done. So here's where a lot of our students are getting stuck. They get here and they want to put 14.2 because they think the remainder must be 0.2. But what we teach is what you probably know. You add a decimal and a 0. That way we still have something to bring down, but by adding the decimal, it doesn't change the value of 72. Again, I'm not talking down to you. I just want to speak like I speak to the students so that you know how you can reinforce it at home. So we put a decimal so that it doesn't change the value. We're not making it 720. We're just adding a digit to bring down, keeping it 72. Whenever you add that digit, one of the reasons it's so important to line up place value is so you put your decimal in the right spot. You bring it straight up. Now we can bring down, and we say 5 goes into 20 how many times? And we'll see that it's not 14.2, that it's 14.4. And since I know 5 times 4 is 20 and it goes in evenly, I'm going to stop right there. All right? So again, when you're doing this, just remind them every time you have them do it, or every time they do it, make them say, why did you put the decimal and the 0? We needed something to bring down, and we didn't want to change the value of 72. Make sure all place values are lined up. All right, so it's already been 7.5 minutes. Let's see how we can get through. We're going to do ratio tables and then a unit rate. So here's what I have been saying to lead them through these types of ratio tables. When we have a problem like this, I always start by saying, when you have the two numbers together, you say, can you do something to 18, multiply or divide to get 3? Is 3 a factor of 18? These are the kinds of questions I ask. And a lot of the times they'll notice, yes, because of sum of digits, 8 plus 1 is 9. 3 is a factor of 9. That's our rule of 3 for rules of divisibility. Some of them just know their math facts and say, well, 3 times 6 is 18. This is one that I refer to as a direct flight. We have a destination we want to get to, and we get to take a direct flight. So instead of doing something here, I just say we can go directly to it by doing what? Dividing by 18 divided by 6 is 3. And then I always say whatever you do to the top, you do to the bottom. Or whatever you do to the bottom, you do to the top. So 18 divided by 6 is 3. 42 divided by 6 is 7. We call these the easy ones because they are a direct flight. You get to go straight to your destination and fill that in. Okay? All right. So then over here, I start the same way. Can we do anything to 18 to get 12? Is there anything, is 12 a factor of 18? No, it's not. Okay, good. Well, that means we're not taking a direct flight. We are taking, and I'm going to pause for your student to tell you, hopefully they know, yep, the scenic route. We're taking the scenic route. And we don't want to just see, we talked a little bit about tourist traps. We don't want to see the world's biggest pancake and end up getting ripped off. We want to see the greatest attraction, the greatest common factor. So that's what's going to go here. Here we got to just go straight to our destination. We didn't stop. We just went straight. Here we're going to stop at the greatest attraction, the GCF. Well, what is the GCF of 18 and 12? I'm not going to go over how I do that. The kids are doing a pretty good job with those. If they are struggling with that, please go back to lesson 1 and do some of those problems. But finding the greatest common factor, hopefully they could find that it is 6. So that's what we want to see. If we're going to have to stop, we might as well see the greatest common factor. All right. What do we do now? We say, how do we go from 18 to 6? Or 6 times what is 18? Well, we're going to divide by 3. And whatever you do to the top, you do to the bottom. And I'm going to assume that I don't know how many times 3 goes into 42. I know it's a factor because 4 plus 2 is 6, and 3 is a factor of 6. So I know 3 will go evenly. But let's say I didn't know, then I would come over here to the right and neatly do my work the same way I did earlier. And rather than take my time, I will go quickly through it using the rules up here. 3 goes into 4 one time, multiply, subtract, get a 1. 1 is less than 3, so I bring down a 2. 3 goes into 12 4 times. So, 42 divided by 3 is 14. So there we saw our attraction, the beautiful GCF, 6 over 14. Now we can go to our destination. We saw the sights, now we're going to our destination. What do you do to 6 to get to 12? You multiply it by 2. Whatever you do to the top, you do to the bottom. 14 times 2. If you needed to work it out, come over here, but we know it's 28. And these are all equivalent ratios. They would all simplify down to 1 unit rate, or 1 common ratio. All right, so you either have your direct flights or you take the scenic route. All right, 12 minutes in. Let's try to get this in the next 3 or 4 minutes so that we're not here all night, so that you aren't here watching this all night. So for unit rates, before I do this, I just want to do the side note that ratios, the difference between a unit rate and ratios they need to know, and they should know, is that a ratio, I told them, you should be excited when you see a ratio because all that means is you just have to simplify it. But in order to simplify, you've got to be able to find a GCF, and you've got to be able to divide, because sometimes it's not as simple as 2 over 4 is 1/2. It might be 42 over 63. You might have to divide 63 by 3, and you have to know your long division. So ratios, you're just simplifying them. Unit rates, you can ask, hopefully your child knows. On a unit rate, the goal is to make your denominator 1. So I'm going to do one that we did in class today. I think we did it in this on-level. 7th on-level is doing something similar. But we did 162 heartbeats. And I take my time because I tell them I'm not very neat either. I can make my stuff look neat because I take my time. All right, 162 heartbeats in 60 seconds. What is that as a unit rate? Well, like I said, the goal of a unit rate is to get it per 1. It's not units rate, it's unit rate. So the goal is to make our divisor 1. So anytime you want your divisor to be 1, you just divide by that same number. A billion divided by a billion is 1. 0.48 divided by 0.48 is 1. Whatever. You divide by the same number. So we get 1 second. Okay? And then I need to do 162 divided by 60. This one's a little more difficult, but still just following the same rules. A house divided by 60. Cannot stand. So fun. Alright, so I set my problem up. And I'm going to show you again the importance of place value, lining things up. You don't have to put these zeros, but I'm going to, again, to show you the importance of place value. 60 goes into 1 0 times. 60 goes into 16 0 times. Sometimes they'll figure out 60 goes into 162 twice, but they might put the 2 like smack dab in the middle for whatever reason. But it doesn't go into 16 twice. It goes into 162 twice. All right, and again, they might need to do the guess and try. Hopefully they would know that right off, but if not, it's okay. But at least come over here and work out. Maybe it's 3 times. They might have to come over here and work that out. They end up getting 180. Okay, that's too much, so they go back to 2. That's fine. But the more that they don't recognize these times tables, like when you take the 0 away, the longer it's going to take them. So that's why those math facts are really important. Recognizing 60 and 160, rounding, things like that. Looking for how many times will 6 go into 16, those kinds of strategies. Those are things you can talk about to speed up work. All right, so then we did the D in does. Now we do the M for McDonald's is multiply. We get 120. We do the cell for subtract. 2 minus 0 is 2. 6 minus 2 is 4. 1 minus 1 is 0. I don't put my zeros often because I feel like it gets in the way. You can put a 0 if you'd like. Is 42 less than 60? All right, good. Then I got my cheese on my burger. I checked. And now I can bring down. Uh-oh, there's nothing to bring down. Exactly. Let's bring down nothing. But first, we need to write nothing. Nothing is 0. Let's add a decimal and a 0. Why? Oh, because we didn't want to change the value of 162. But we needed something, technically nothing, to bring down. Whenever I add a decimal in the dividend, I put it in my quotient. Whenever I put a decimal in the house, I bring it straight up. And I can bring down my 0. I'm going to go ahead and do the arrow. And then I say 60 goes into 42 how many times? And again, I prefer you not put the slashes, but I do tell them, recognize the 0 trick. All right, they're multiples of 10. 6 goes into 42 is basically what you could ask yourself. 6 goes into 42. Well, if you didn't know, you can come over. Really, that's a basic math fact. You need to know it. Doing long divisions. Not really going to help, but 6 times 7 is 42. And since I know 60 times 7 is 420, it goes in evenly, I'm going to stop. And that's long division. It can be tricky, but once you do the steps, once you break it down and you just do some practice, there's no one in this class that can't do it. All right, we're all bright enough to be able to do it. So 2.7, and where partial quotient starts getting messed up is they might say 60 goes into 162 once. They put a 1 over here. They subtract 60. They get 102. They say 60 goes into that once. They put a 1 over here. That's easy. Add 1 plus 1. They get their 2. But then they're left with 42, and they say, well, 60 doesn't go into 42. And it becomes a mess because there's not really much room to work with decimals. Or they might forget to put a decimal. Or they might put a, sorry to go on a little rabbit trail here, but just to defend this, in partial quotients, they put their partial quotients over here to the side, and they might say it goes in once, and then if they have a 0.7 and they're not lining up their place values, I've seen it so many times where they might say 9, or they might say 0.9, because there's not, unless they're, you could teach, and it's not saying it's impossible, but it's just lots of room for silly mistakes doing the partial quotients. If you don't do partial quotients, sorry about that 45 seconds, but that's why I suggest classic long division. And then we always want to label it heartbeats. You could put HB, I don't care. All right, so that was almost 20 minutes of time that you invested into watching this. But just remember a few things in a quick recap. We always say a house divided by the number tells you how to set it up. Even if you're talking, what's 48 divided by 3? Well, it's a house divided by 3, the number in the house. We line up our place values. Whenever we add a decimal, it's to not change the value, and we bring it straight up. Ratio tables, you either have your direct flight, straight to it, whatever you do at the top, you do at the bottom, or you have to find the GCF. And that has to be your scenic route. You're going to see the big attraction of the GCF. Then you can make it a pit stop, and then you go to your destination. Here, we want a unit rate, which means we want our denominator to be 1, and that's how we divide. If you can do these, you'll be set. But you can see there's a lot. It's not that one thing is too difficult. It just takes thinking, and it takes a lot of steps, so it's a lot of room for silly mistakes. But thanks for checking in. Thanks for all the help you do with your students. And students, if you're watching this, good job. Way to put in some extra work, extra time. Keep practicing. I'm here if you need any help. Reach out. Good night and God bless.